Hi everyone. Okay, so we are moving on. Module 4, Topic 1, Lesson 4, Activity 1 on page 389. Okay, so it says determining whether expressions are equivalent. Two algebraic expressions are equivalent expressions if, when any values are substituted for the variables, the results are equal. So when you substitute in a number, the same number, in for the same variable in different expressions, if you end up with the same result, then they are equivalent. While it's not realistic to test each expression for every possible value for the unknown, you can examine the characteristics of each expression in the different representations. So we can look at it through a table of values, a graph of both expressions, or rewritten expressions using the properties. So we're going to look at each of those. The first one that we're going to look at is how you can check to see if two expressions are the same by using a table of values. Okay, so let's get started. So it says, consider the two expressions. 2 times the quantity of x plus 2 plus 3x and 5x plus 4. Then it says, let's explore each representation. Complete the table of values for each value of x. Right, I'm going to get an additional piece of paper just to kind of write on here to the side because it's going to get very crowded in there if I don't. Okay, so I'm going to rewrite this expression. The first one says 2 times the quantity of x plus 2 plus 3x, and then the next one is 5x plus 4. Okay, and we are supposed to check that for 0, 1, and 2. And 3. 0, 1, 2, and 3. I'm going to slide this over. Okay, so when x is 0, what do we get here? So if we substitute 0 in for the x, and we solve this, what do we get for this one? So do the parentheses first. 0 plus 2 is 2 plus 3 times 0. Okay, now we're going to multiply in order left to right. 2 times 2 is 4 plus 3 times 0 is 0. So we get an answer of 4. Okay, so let's check this one then. So if we substitute 0 in for the x plus 4, we get 5 times 0 is 0 plus 4 is 4. So notice we got the same result when substituting 0 in for each. So over here on our table, I'm going to write a 4 and a 4 for each of those. Now, I don't care if you show your work on the side. You might want to try to write it real small in the box, or if you want to get an additional piece of paper, you can do that. Just like label it, so page 389, and then like number 1. Okay, so I'm going to underline this here because this is where we see the expressions that we're using and the value of x. So, and then I'm just going to kind of go like this to show that I'm now going to move on. So I just did this. I underlined it, and then I separated it here. Okay, I'm going to try to zoom out a bit. See if I can slide this up and you can still see it. Trying to just get a different angle of my camera so that things can be a little bit more close up. All right, so I guess I better rewrite this or else we're not going to have it all in the view. Okay, so now we are checking for the value of 1. Okay, so 2 times 1 plus 2 plus 3 times 1. So anywhere that there was an x, I'm substituting in a 1. So 5 times 1 plus 4. inside the parentheses, we have 2 times 1 plus 2 is 3, plus 3 times 1. And now we're going to multiply across. 2 times 3 is 6, plus 3 times 1 is 3. We have a total value of 9. So let's finish up this one. 5 times 1 is 5, plus 4, we have a value of 9. So when x is 1, this expression equals 9 for each of them. Okay. All right, so like I'll try to put it inside here and see kind of what happens. I think there's just too much. So 2 times the quantity of 2 plus 2 plus 3 times 2. So here we have 2 times 4 plus 3 times 2. See, I just don't have enough room in there to write it all. Okay, so I'm going to finish it up over here. So we have 2 times x plus 2 plus 3x. And we are doing when x equals 2. So we have 2 times 2 plus 2 plus 3 times 2. So 2 times 4 plus the 3 times 2. We have 2 times 4 is 8 plus, and we can do this one right now, 3 times 2 is 6. Add those together, we get 14. And there we go, just came in focus. And then the other expression was 5x plus 4. We're going to substitute a 2 in. 5 times 2 is 10, plus 4 is 14. So really on this table here, I'm going to erase it because I don't like all of that being in that teeny tiny little box. So 14 and 14. Okay, and then finally we're going to do the number 3. So we have 2 times x plus 2 plus 3x and 5x plus 4 when x equals 3. So 2 times 3 plus 2 plus 3 times 3. So x is 3. I'm going to fill it in right here as well. Okay, so 3 plus 2, because it's in parentheses, we'll do that first. Okay, 2 times 5 is 10, plus 3 times 3 is 9. We end up with 19. For this expression, 5 times 3 is 15, plus 4, and we get 19. So 3 is the value of each of these expressions. When x is 3, it is 19. Okay, so then it says, can you determine based on the set of values, what can you determine based on the set of values inside the table? So what can you determine? So we could say no matter which value of x is substituted, the results are the same for each expression. In other words, when we substitute a 0, we get a 4 for each. We substitute a 1, we got a 9 for each. Substitute a 2, got a 14, and a 3, we got a 19. Okay, so then it says, what do you need to know to verify that the two expressions are equivalent? Well, in a table, it kind of hints to it up here. It says, while it's not realistic to test each expression for every possible value for the unknown, you can examine the characteristics in different representations, and it gives these. So to know for sure, we would have to, and it's what we did, calculate the value of each expression for all values of x. Oh my gosh. Okay, you can pause if you need to finish writing. I'm going to flip it so that I can try to keep the video not too terribly long. Okay, so on page 390 then it says, you can also use a graph to determine or verify whether two expressions are equivalent. Consider your completed table of values from question 1. And would you look at that? They give them to us right here. It says plot the values for each expression on the coordinate plane. Then connect the results for each expression with a line. So we have an x value, and then remember this is really our outcome, or it's our y. What would be here on the y-axis for each of these? We're substituting in for x to see what we would get on the other side, which is the y. So when x is 0, y is 4. So we're going to go over 0 and up to 4. And then x is 1, we go up to 9. Here's 1 and 9, 2 and 14, and 3 and 19, and then we're supposed to connect the line. Okay, I have a little straight edge right here. Okay, now if I do that for the other column, what do you guys notice happens? So it's still 0, 4. It's still in the same spot. It's still 1, 9. So they are the same line. So how does the graph demonstrate that the two expressions are equivalent? So how would you put that into your words? Like when I would connect those green dots, we're going to get literally the same line. So that's what we can write. They are the same line. Then the third way that we can check is by rewriting the given expression, and we'll identify the property at each step. So I just want to flip back over here. It told us the 3 ways we could do this was a table of values, a graph of both expressions, which we just did, and then rewritten expressions using the properties. So this first expression, this one, 2 times the quantity of x plus 2 plus 3x, has been rewritten right here. And they're telling us that's the given. In other words, that's what we start with. So then what can we do, and what are they doing? What did they start here? We ended up right away with a 2x. So they're taking that 2 and they're distributing it to the x. So we have 2 times x, and we know that the 2 gets distributed to everything inside the parentheses. So 2 times 2 will give us 4, and then we have the plus 3x, and that is the distributive property. And then it's going to tell us that what it wants us to do next, combine like terms. So my like terms, this is an x term, and this has an x, so we're going to combine them. So 2x plus 3x is 5x. There's nothing for us to combine the 4 with, so we keep it as a 4. So it says, are the two expressions equivalent? So we ended up with 5x plus 4, and what was the second one we were given? 5x plus 4. So are the two expressions equivalent? Yes. When you distribute, it says explain, and combine like terms, you get the same expression. Okay, you can pause. This has been 16 minutes, so I'm going to do the next 2 pages on another video for a part 2 of activity 1.